Introduction to exercise 5E on the surface area of prisms and pyramids on page 324 of your textbook. We've looked at area and perimeter. I don't know why that took me so long. Area and perimeter. But we also talked about how, let's be honest, the second dimension was invented by us to explain the third dimension. So let's jump into the more relevant third dimension and look at not only the area, but the surface area. So the area on the outside of each of these objects, and then the we can look at the perimeter as well, but let's focus on the surface area for now. So the total surface area of a solid is the sum of all areas of all the surfaces. That's it. So imagine if you were to paint the outside, how much paint would you need? That's pretty much what we're looking at. Okay? And sometimes it's more beneficial, more easy for us to break down a three-dimensional shape into a two-dimensional shape to make it a little bit easier to understand. Now, it might work for some of you, it might not work, it doesn't matter. I'm not going to give you a test question that says, break this down to a net. I feel like that's not as helpful, but if that helps for you, you're more than welcome to do it. So a net is a two-dimensional illustration of the surfaces of a solid. It just makes it easy for us to see all the outside surfaces on a flat plane. Finally, a right prism is a solid with uniform cross-section with two identical ends, and the remaining sides are rectangles. Now what that means is saying that if we're talking about a right prism, if I cut it down the middle, right, imagine if you're cutting a cake, for example, cutting a piece of cheese, whatever it is, it should be the same shape there as it is on the other end. And also, both ends have to be the same, right? So if you start off with a rectangle on one side and it turns into a papaya shape, I don't know what's the first shape I thought of, then it's not a right prism. Yeah, pretty straightforward. And of course the other sides are rectangles. So triangular prism, rectangular prism, they're all right prisms. Okay. So just like we did last time, I'm not going to get us to try and write down a formula and use it. Let's try to create the formula itself. Okay. So in the solid on the left-hand side, can you guys see that up the back? Yeah. Lovely. Left-hand side, we've got a rectangular prism where we've got our length, width, and height defined by variables that we don't know in this case. So what we're doing is, again, creating a general formula, a formula that would work for any size shape that's similar to this one, but we're going to answer it in variables. So to calculate the total surface area, it makes sense that we can just break it down to different sides. So I'm going to say that the total surface area of this shape equals, let's do 2 times, and there's a couple of ways you can write this. I'm going to make it a little bit easier. 2 times top plus sides plus ends. So what I'm saying is it's going to be 2 times the top, which is just this area here, 2 times the sides, which is I'm talking about this area here, and then 2 times ends, which is this area here. Any qualms with that? Yeah.
What about the bottom?
The bottom, so I'm multiplying everything by 2. So I'm only focusing on this top one here, which when I double will include the bottom. If I focus on this one here, if I double that will include the left-hand side, and this side here, which I double, will be the other side as well. Good question. So the total surface area equals the 2 times bracket the top, which is length times width. So I'm going to write LW plus the side, which is WH, and finally plus the end, which ends up being LH. You can rewrite this as 2LW plus 2WH plus 2LH. That works as well. They're the same thing. Either one of them works, as long as you've got one of those formulas there for you. Any questions? Okay. So let's look at the square-based pyramid. Similar idea, except for the total surface area of this one, we know that equals to the base, that's the bottom part, plus 4 times a side. Because it's a square base, we're assuming that each of the bottom lengths are the same, and therefore the sides are all the same. So I just need to add the base and the 4 triangular faces. To find that, I know that the base is equal to the base, or the length of the base, squared, this is a square, we're just going base times base, plus 4 times, and to calculate the side, it's going to be half times base times height. Agreed? Which we can then simplify to give us b squared plus, and half of 4 gives us 2, so 2bh. If you remember our stuff from simplifying quadratics, we can say or b brackets b plus 2h. They both work, again, just in different forms, but they're the same thing. At the end of the day, you're going to be using, most likely, these two formulas here. So again, having those formulas in your notebook is going to be very helpful. That's a general formula. Assuming it's a square-based pyramid or a rectangular prism, it will always work for those. Let's give it a shot at using them. So, find the total surface area of this right rectangular prism. They mean right as in the shape is right, not right as in it's on the right. And this right square-based pyramid, same thing. So, let's write down the formula first. So, I'm going to say that the total surface area of this shape, and I'm using the first formula now, is 2 bracket LW plus WH plus LH. What I'm going to do, and again, you don't have to do this, but this is just my way of making it super clear for anyone who's reading it, assessing it, checking it, etc. I'm going to say L equals 7, the length of it. W, the width, equals 3. And H equals to 8. Here's the thing. Doesn't matter if my length is 3 and my width is 7. No, it won't change my answer, will it? It won't change my answer. So therefore, it doesn't matter which one I use. Right? So let's say, for example, L is 7, W is 3, and H is 8. Putting those numbers in, I get 2 bracket L times W, which is 7 times 3, plus W times H, which is 3 times 8, plus L times H, which is 7 times 8. And you notice that no multiplication should be the same. If it is the same, so for example, you've got all different numbers, but then you've got 3 times 7 and 7 times 3, you've done something wrong. 7 times 3 is 21, plus 3 times 8 is 24, plus 7 times 8 is 56. 21 plus 24 is 45, plus 56, which gives us 2 times 101. That's correct, which gives us an answer of 202. Are we done? Happy to move on? Yeah. Thank you very much. Meters squared, remember, because it's a total surface area. Even though we're working with a 3-dimensional shape, what we're looking for is a 2-dimensional shape. So the area is a 2-dimensional value, so therefore to the power of 2, or meters squared. Great. I'll quickly go through this next one. This one should be a little bit easier in my opinion, but we'll go through this one, and then I'll get you guys started on exercise questions. So the formula for this one was b squared plus 2bh. So let's label b equals to 5 and h equals to 6. Now in this case, doesn't matter which one I use. Can I say that the height is 5 and the base is 6? No. Why is it different?
Because if h is base, it's hard to calculate.
So if h is base, then
if you're going to rotate it, then it'll be hard to.
Yeah, it'd be really complicated. Exactly right. So if in the other one we substituted L, W, H as different values, as long as they're correct, it's fine. But in this case, b squared, only the base is squared. If they're different values, then it's going to get you something incorrect. So just make sure you know which one is which in this case. Which equals to, I'm substituting my values in. 5 squared plus 2 times 5 times 6. Just replacing those letters with the numbers there. Which gives us 25 plus 60, which is 85. And of course, cannot forget meters squared. Any questions? Seems relatively familiar. Awesome. I'll get you started on exercise 5E questions, and we'll go from there. Thank you very much.